I want you to stop for a second and think about this. At this very moment, as you're watching this video, quadrillions of tiny invisible particles are streaming from the sun. They're passing directly through your body, through the floor beneath you, and traveling straight through the entire planet Earth without stopping. And the craziest part? You don't feel a thing. These are neutrinos, the ghost particles of the cosmos. And by learning how to finally see them, we're unlocking a completely new way to understand our sun, distant stars, and the very fabric of the universe. So let's talk about our sun. We all see it as this giant ball of light and heat in the sky. We know it's a massive nuclear furnace, but what's really going on deep inside its core? We've always learned that the sun fuses hydrogen atoms into helium, releasing the energy that powers our solar system. That's the classic story. But that process creates something else, a byproduct that carries the sun's deepest secrets directly to us. That something is the neutrino. Picture a particle so small it has almost no mass, and it carries no electric charge. This means it almost never interacts with anything. It's like a perfect ghost. While photons, the particles of light, take tens of thousands of years to bounce their way out from the sun's core to its surface, neutrinos zip out at nearly the speed of light in just a few seconds. They are true messengers, carrying pristine, real-time information straight from the heart of the fire. Right now, literally billions of these solar neutrinos are passing through your thumbnail every single second. They traveled 93 million miles from the sun's core and are now going through you, me, and everything around us as if we weren't even here. How do we catch something that doesn't want to be caught? Well, that's where human ingenuity gets really impressive. For decades, scientists knew these particles had to exist based on their theories, but they couldn't prove it. Catching a neutrino is like trying to catch a single, specific grain of sand in a hurricane, with your eyes closed. To solve this, scientists had to think big. And I mean really big. They went deep underground to shield their experiments from all other cosmic radiation. Imagine giant detectors, some the size of an Olympic swimming pool, filled with hundreds of thousands of gallons of ultra-pure water. These tanks are lined with thousands of incredibly sensitive light detectors. The idea is that, very, very rarely, a single neutrino out of the countless trillions passing through will happen to strike the nucleus of an atom in the water. When this impossibly rare event happens, it creates a tiny, faint flash of blue light. It's this ghost of a flash that the detectors are waiting to see. From huge tanks of cleaning fluid in old gold mines to giant spherical observatories buried under the Antarctic ice, we have gone to incredible lengths just to glimpse these fleeting messengers. But when we finally started catching them, a new, even bigger mystery appeared. Our theories predicted a certain number of neutrinos should be arriving from the sun, but our experiments were only finding about a third of that number. Where were the missing neutrinos? It was a massive scientific headache known as the solar neutrino problem, and it stumped physicists for years. Did our understanding of the sun have a major flaw? Or was something even stranger going on? The solution, when it came, was revolutionary. It turned out our detectors were only built to see one specific flavor or type of neutrino. Scientists discovered that neutrinos are cosmic chameleons. As they travel from the sun to the Earth, they can spontaneously change from one type into another. So the neutrinos weren't missing at all. They were just arriving in disguise. This discovery that neutrinos have mass, however tiny, and can change their identity was a monumental breakthrough. It completely changed our fundamental model of particle physics and proved that we were finally, truly seeing inside our star. And the story doesn't end with our sun. Neutrinos are forged in the most violent and extreme events the cosmos has to offer. When a massive star dies in a cataclysmic supernova explosion, it unleashes a blast of neutrinos that carries away most of the explosion's energy. These cosmic neutrinos travel across galaxies for millions of years, carrying eyewitness accounts of stellar death. By detecting them, we're opening a brand new window into the universe. It's called neutrino astronomy. Instead of just looking at the universe through light, we can now sense it through its most ghostly particles, peering into places that light can never escape from, like the hearts of exploding stars or the regions around supermassive black holes. From revealing the inner workings of our own star to giving us a front-row seat to cosmic catastrophes, these nearly weightless, invisible particles hold the keys to some of the biggest unanswered questions in science. What is the true nature of matter? Why is there more matter than antimatter in the universe? The humble, ghostly neutrino might just have the answers. Thanks so much for joining me on this journey into the invisible. If you enjoyed this and want to explore more of the universe's hidden secrets, make sure to hit that like button and subscribe to the channel so you don't miss our next adventure. We'll see you in the next video, and until then, keep looking up.